Cylinder or tube lights are, well, the clue's in the name really. They're fluorescent or similar shaped tubes of light that are commonly used in the film, photography and music video industries, as well as very useful in ArcViz and product renderings. Plus, they're also really good at making lightsabers. They emit a soft and diffuse quality of light, which results in a less harsh shadows, and the thin reflections they produce are often used to highlight the shapes and forms of the subject. They also are very visual, and you'll often see them not only being used as practical lighting, but also as visual props as well. They can also be used individually, spread across the location, or grouped together to create visual light sculptures, structures, lines, and patterns of light. So, how do we make these in Solaris? Well, let me show you. So here in Solaris, you can see that we've got our default scene, and in the middle here, we've still got our Reflectotron robot. And the scene is being illuminated by a very dark HDRI, which I've rendered out from the actual studio with no lights on. And these reflections here are actually coming from a door which has been opened at the very far end of the studio. So the first thing we need to do is we need to drop in a light. And we then plug that into our merge node. And the first thing you'll see that when you drop in a new light is that by default, Solaris always wants to make the type of light to a point light. So to make a cylinder light, all we need to do is come up here and we select cylinder. And so here what we get is we get our cylinder light. And so I'm just going to change the shape of it. I'm going to drop the radius down something like 0.2, actually 0.1. And I'm going to make the length of it, say 3 meters. And if I just bring it up a bit and put it over the top of him. In fact, I'm going to make it a bit thinner. And raise it up a little bit more. So now what you can start to instantly see is the tube light instantly creates us these thin and sharp reflections, which, like I mentioned in the intro, they're very useful for sort of really defining the shape and form of a model or a subject that you're trying to render. So here you can see we have our base properties. We have intensity, which we've learnt about, and we have our exposure. You can change the color of it. And you know that if we want to use the color temperature, we need to reduce the hue down to white. And so now we can then adjust the color temperature of our cylinder light. And here we have our radius and our length that we looked at before. And then here we have our normalized power on or off. And as we learned in a previous lesson, this is how we control our diffuse and specular multipliers. Now, the other interesting thing that I haven't showed you yet is over in the RenderMan tab. And if you scroll down at the bottom here, we have this visibility. So there might be times, for instance, when you're doing renders with a cylinder or any other light in Solaris where you don't want it to be visible to the camera. And so all we need to do is we need to change this from do nothing, and then we need to change this to set or create. And by turning this off, and now you can see that what happens is that the cylinder light is not visible to the camera, yet we're still getting the emission from that light. And so that's pretty much it for cylinder lights, and I'll see you in the next one. All right, okay, I'm just kidding, because there are much more to cylinder lights than just that. The first thing about photorealistic cylinder lights is that they can either produce a solid color or they can be programmed with color light ramps. Another thing we notice is that the tops and the bottoms of cylinder lights are also darker, and this is caused by the caps on the top and the bottom of the actual tube lights themselves. And lastly, the center of a cylinder light is often brighter than the glancing angle or the edges. So let's turn our boring cylinder light into something which matches the real-world tube lights much more accurately. But the problem is that Solaris has a few limitations in the fact that we can't texture our cylinder lights with a ramp or a texture. But thanks to the creative power of RenderMan, we can overcome this. So let me show you how you can take your cylinder lights to their next level and make them look a lot more photorealistic. So here we have a new scene, and all I've really done is I've pruned out the robot and his power. And then using this SOP import, I brought in some geometry that I've modeled of an actual tube light with its stand as well. And I've also created a new cylinder light which sits directly in the middle of this tube light here. And then let me just show you how this tube light works. So if I increase its intensity and exposure to 2, so now you can see that what we're starting to get is pretty much what we already had in the first part of this lesson. And if I just increase the exposure to 4, you can really see it. We've got this cylinder of light that sits in the middle of this geometry. And so let me show you where the magic really starts to come into play, where we can turn this normal boring cylinder light into a much more of a photorealistic tube light that we would get in the real world. And that magic comes from a material that sits inside this material library, which is actually applied to this piece of geometry that sits just outside of the cylinder light. So if I dive inside of the material library, you can see here that we have our tube light material. And again, like I said, this tube light material is applied to this piece of geometry that sits here. And if I jump inside of it, you can see here that, well, I've called it glass matte. So there's a clue in the name here. It's actually a glass material. So what we actually have is we have a cylinder light that is sitting just inside of this glass material. And this is where we're going to start to really push this look. And I can show you that. So if I come over to the glass tab of our Pixar surface and I reduce the refraction gain down, because we have no refraction on this glass, it's actually blocking out all of the light completely. So let me put that back up to 1 to let the light come through this glass material. Now everything else is set pretty much to its default. The only things I've changed is I've changed this roughness down to 0. And we're going to have a play with this a little bit later to really sort of dial in a number of other little looks that we can get from our tube light. And I've left the refraction index to 1, and I've just checked this thin box here, which basically tells RenderMan that you still want it to be glass, but you don't want any refraction. And again, these are creative parameters that you can use and dial in to sort of match your real world reference or the creative look that you're going for. And so those of you who have already spotted that I've got 2 extra nodes that sit in this material library, and this is really where the magic starts to happen. So here I have a Pixar blend, and I have 2 colors in it. I have a top color of pink and I have a bottom color of black, but my operation is set to normal. Now this starts to really come into its own when I take out the result RGB and I plug it into my refraction color. And to really sort of push this effect, what I also want to do is take out the result RGB and I want to plug that into the shadow color. And so now what we've got is we've got this pink light, and this is controlled with this top color. And so you can see here that whatever color we want to create, we basically use this top color to drive the color of our light. But we're not really driving the color of our light, because if you remember, our light is white. But what's actually really happening is we're using our refraction color and our shadow color, which is being driven by the color which is defined in our top color of our Pixar blend. Now, again, this looks roughly where we were. All we've done is we've changed the color. But taking it one step further, and as I mentioned before, what we really want to do is we want to apply a ramp to this to really dial in the look, because normally in tube lights in the real world, the top of the light and the bottom of the light are actually darker. And this I can achieve by taking this ramp. And if I just show you the ramp here, I've got a simple black and white ramp where I've got black and then it goes to these white values and then it goes back down to black. And then I've set it to the T value. So it's going to go from the top to the bottom of our glass tube. And if I take out the result RGB and I plug it into the bottom of our Pixar blend, nothing's really going to happen. But what I need to do is change the operation to multiply. And now what you'll start to see is we're multiplying the output of our black and white ramp over the top of our color. So if I take this to say orange, now I can adjust my Pixar ramp node to start to adjust how the gradient falls off at the top and the bottom. So if I want to adjust the bottom, all I need to do is start to bring this white value down towards the black. And now you can start to see here at the bottom we've got less, and I'll just make it more exaggerated by taking up even further. So now you can start to see that we've got a much darker bottom of a dark orange, and then as we get up towards the middle, we've got a much more brighter orange. And then again, I can do the same for the top. If I move this white value, now we get more darkening at the top of our tube. And if I move it closer to the black, we get less darkening at the top of our tube. And so what we can do is we can also start to drive how this color is being affected with another ramp, because at the minute it's just this kind of solid orange color. A lot of the tube lights in the real world, you can actually sort of dynamically run sort of patterns and ramps and all sorts of funky colors through them. So we can do this by putting down another Pixar ramp, And then instead of driving our main light color with this top color, which is currently orange, we can then plug in another ramp into the top. And so the Pixar ramp also comes with a number of presets. So let's have a look at a few of these. Let's have a look at Inferno. Now that's not terribly brilliant, but what we need to do is we need to change the ramp type to T. So now what we're starting to get is we've got this purpley blue color at the bottom, and then we've got this light orange yellow color at the top. And you can also press tile as well, so you can plug in a manifold and actually create tiling of these colors. So let's have another look. Let's try plasma, see how that one looks. And this is where the shadow color really starts to become apparent, because you can see in the shadows that we're getting this purple, and then it sort of goes out to this magenta-y pink color as well. Let's try one more. Let's try Twilight. Let's try one more because I wasn't that pleased with it. Let's try infrared. And so again, just to reiterate, you've got red at the top, and then we've got this purple at the bottom. And if we want more red, we can just drag the slider further in. Now we get this red, and then the gradient, we can start to play around with it to really start to kind of enhance the way our patterns look. Now, like I said to you before, you can start to sort of use some of these roughness values to actually start to stylistically control how the tube light looks. If we start to increase our roughness to say something like 0.5, now we're starting to get a bit more of a blend, and we can take it all the way up to 1. And now what we're getting is this kind of much more of a kind of plastic tube that sits here. So it's not so glassy, and it's got a bit of plastic vibe to it. And then we can start to also bring up the reflection gain. So that if we had other objects and other lights, we would start to get reflections on our glass tube as well. And so one more extra trick I just wanted to show you before we finish this lesson was how you can use the Pixar Vary node to control the difference in colors between duplicates of your cylinder lights. So what I've done is I've very simply just used the duplicate node in Solaris, and I duplicated up our single tube light, and now I've made 5 of them. And instead of using a solid color in the top of our Pixar blend, I plugged in a Pixar Vary. And so we're not going to see anything very much happening at the minute because our input color is set to white. But if I increase the saturations, so now what we've got is we've got all orange lights. And as we know in previous lessons from the original Fundamentals series, if I now start to increase the hue, and now what it'll do is it'll cycle through the hues. And this may be something that you want. You may want different hues for each of the lights. And so if I come here to green, you can now see that we start to get a bunch of different hues based off this green value, and also this centered control as well. But you may just want to sort of set a base color. So if we want orange, or let's go for a different color, let's go for a dark blue color. And then maybe we want each of these tubes to have a slightly different luminance to them. So some are brighter, so this one's brighter than this one, for instance. Or we may want to change the saturation on them. So this one's, again, a lot more darker. So just to summarize, using a Pixar Vary and applying it to duplicates of your tube lights will now start to vary up how the intensity and the color and the gamma of your duplicate, which is incredibly powerful because not all lights in the real world actually always have the same intensity values or the same color values. Well, I hope this lesson has been inspiring for you, and it's shown you how you can turn a normal, boring cylinder light into a much more visually interesting and pleasing tube light, and then harnessing the power of the Pixar Vary to get some really interesting and subtle visual changes between all your duplicates.